Hello, everybody, and welcome to this presentation from Jenks, who's CEO of SmartKem. Ian's going to give us a presentation on Moore's Law and the display industry. As always, we will be taking live questions after the presentation, so do please leave these in the sidebar. I will now turn off my camera, hand over to Ian, and I'll rejoin you at the end of the talk to take the questions. Over to you, Ian.
Very much. So before we start, just a few seconds, either right enough to read those. So good morning, everyone. It's a pleasure to be presenting today, although it's a little intimidating in such illustrious company. I'm Ian Jenks. I'm the chairman and CEO of SmartKem Inc. We're new to TechBlick and we're new to the markets, having gone public in March. And hopefully our stock will start trading in a couple of weeks. By way of background, we have approximately 40 people spread over 2 sites in the UK, one in Manchester developing core chemistry, and one at the UK's Centre for Process Innovation developing process technology. We also have applications and business development teams in Taiwan, Japan, and the West Coast of America. We're an advanced materials company specialising in the design and supply of organic semiconductors and passive interlayer materials for use in printed electronics. On a personal note, I'm a self-confessed photon junkie. And in that capacity, I've run public and private companies on both sides of the Atlantic. I've also built and run quite a few cyanide and wafer fabs. Today I'm going to talk about the display industry, but ourselves of what it's not. Moore's law is, in a dense integrated circuit, doubles about every 2 years. It's an observation and a projection of a historical trend. It is not a law of physics. It's an empirical relationship and is linked to gains from experience in production. And just wow. I mean, I started in the semiconductor industry in the late 80s. I think we were on about a 1 micron design rule with around 100,000 transistors on an IC. Last year, 50 billion. That's 50 billion transistors on an IC. In fact, I think the latest NVIDIA video chips over 60 billion. And we have a 5 nanometer design rule. The power of 2 is mind-boggling. But that whole industry is designed around the need for high-speed, super-dense processing. Processors do a lot more, but cost even greater amounts to develop. I'm told it's perhaps $50 million for a chip at a 5 nanometer node. And they need ever more expensive capital investment. And so the cost of a chip is still a few $100s. So with apologies to Winnie the Pooh, that started me thinking. So in today's world, I don't think we have enough time to just think. I'm very fond of occasionally having a bath rather than a shower. It's my thinking time. And a while ago, I was thinking about display backplanes. I think that is the definition of a photon junkie, thinking about displays in the bath. And I wondered why. If you can make tens of billions of transistors for a couple of $100s, that means they're free. And we only need a few thousand, then why aren't display backplanes made on silicon? Well, the answer, of course, is at its most basic level, silicon is too expensive. Silicon wafers cost, $10 a square inch, and a processed silicon wafer a few $100s a square inch. Yes, I know it's much more complicated than that, and it depends on the node size, cost of design, prototyping, packaging, and testing. But in the display industry, we need square yards, not square inches. And it's the same problem I face time and time again with people presenting new ideas for photonics products. They wanted them made at wafer scale, and as far as they were concerned, that meant ever decreasing cost.